This is the Math 2 lesson summary video for the lesson entitled Measured Reasoning. In Lesson 5, Measured Reasoning of Unit 7, the purpose of this lesson is to practice applying the theorems of this unit and previous units. The theorems include the vertical angles theorem, the triangle sum theorem, alternate interior-exterior angle theorems, corresponding angles postulate, and the side splitter theorem from the previous task. The theorems include vertical angles are always congruent. The measures of interior angles of a triangle sum is 180 degrees. When transversals cross parallel lines, alternate interior angles are congruent and corresponding angles are also congruent. And a line parallel to one side of a triangle divides the other two sides proportionally, which is also known as the side splitter theorem. In the first part of Lesson 5, Measured Reasoning, we are asked to find the measures of all the missing sides and angles by using geometric reasoning, not rulers or protractors. So we were given this diagram and then we were told that lines P, Q, R, and S are parallel. So on this diagram, because we are given that those lines are parallel, I will mark them as parallel, which in math we just draw arrows. So P, Q, R, and S. And we're asked to fill in all the missing information. So let's start with the quadrilateral on the bottom there. So we definitely can see that one angle is right, and so we do know that this one is right because these two angles added together should be supplementary or add to 180. If these two bottom angles are right, then we do know that these top two are right as well, which means this is a rectangle. So these lengths are 18 and 12. And again, using the same reasoning, this would be a 90-degree angle because those two angles have to add to 180. So let's look at the bottom triangle. We can use Pythagorean theorem, 9 squared plus 12 squared equals x squared. And we get 81 plus 144 equals x squared. And we solve that for x, we should get 15. So this length of that right triangle using Pythagorean theorem should be 15. We can also find the angle that's missing up here. If we do 180 minus 53, 180 degrees minus 53 minus 90, because we know the sum of the angles in a triangle is 180 degrees. So this angle here should be 37 degrees. Okay, so now let's take a look. We do know that our lines are parallel. So we have two parallel lines and we do have a transversal. We can call this here that I'm going to outline as a transversal. So if you recall from a previous unit, when we have two parallel lines cut by a transversal, we have what we call congruent alternate interior angles. So if this angle down here is 53 degrees, we do know that this one is 53 degrees also. By the supplementary angles or linear pairs postulate, we know that those two angles add to 180, so the missing angle here is 127 degrees. So what we're doing is we're using our prior knowledge to fill in all the missing information in the diagram. So let's take a look and see what else we can fill in. So we do know by using the same method, let's see what else we have here. If I scroll up here, I do know that this angle would be 146.3 degrees because again, these two are linear pairs or supplementary, so they should add to 180. I also know that this angle of 33.7 degrees should be congruent to this angle here because, and let me just make that a little bit more clear for you, because they are vertical angles, and vertical angles always share a vertex, and they're always congruent in measure. So those two would be filled out. Now, if I look, I do know that P is parallel to Q, so corresponding angles should be congruent. So that 33.7 corresponds with this angle here, so they should also be congruent. Likewise, these two are vertical, so this angle should be 146.3 degrees. So I've filled in some more angles based on the vertical angles theorem. The vertical angles always add or are always congruent. And then I noticed that this 53 degrees would correspond to that one. So I did mark that one as 53 degrees. Now, if we take a look at this diagram, these three angles should add to 180. So I can perform the operation 180 minus 53 and minus 33.7. And I should get the missing angle, which should be 93.3 degrees. So I'm going to label this one here as 93.3 degrees. And now I do have a triangle at the top, so I can do the same thing and add 33.7 plus 93.3 degrees, subtract it from 180, and I do notice I get 53 degrees. And that makes sense because this angle here, 53, does correspond with that one. And again, supplementary angles add to 180. So notice we're using the same theorems to help fill this out. So that should be 127 degrees for this angle. All right, so now we have a little right triangle, 3 squared plus 4 squared. This is called the Pythagorean triple. We should be able to solve that and get 5 for x, or we should know that that length is 5 of that side. We do know that this is a right angle here. And let's see what other missing information. We do know this is a right angle here. And let's see, we do know this angle is 93.3 degrees because it is vertical with the other angle of 93.3 degrees. And then we can find the third missing angle in that triangle. And it should be 33.7. So we have two ways to find that. You can add the 53 and the 93.3 and subtract it from 180, or because they're parallel lines, we have alternate interior angles. So I'm going to finish filling these in. We did go through all of them in class, using our knowledge of the triangle sum theorem, using our knowledge of Pythagorean theorem, our prior knowledge on alternate interior angles, alternate exterior angles. So let's see what else we're missing. That's 90, 90, 90, 12, 12, and I think we have everything, I believe. And if we miss something, we'll get to it in a moment. And this length is 16.97. 12 squared plus 12 squared equals x squared, and then we solve for x. So I wrote that as a decimal. Okay, so then in the next part of this investigation, we're asked to identify, in this case, at least 3 different quadrilaterals. So we're going to call that a quadrilateral is a 4-sided figure, and then they asked us to find the sum. So I'm going to come back here and I'm going to use a highlighter. We want to find some quadrilaterals. So let's take a look, and I'll use a color here. I need 4-sided, so I'll just use a little blue. And I do see a quadrilateral, 4-sided quadrilateral right here. It does have 4 sides. And we're asked to find the sum of all the angles. So the sum of all the angles, I would add 33.7, and this would be 90, because all of those angles are 90, plus 90, plus 53, plus 93.3. So the sum of that one would be 360 degrees. So let's write that down. So that's one example. Sum of the blue quadrilateral, my apologies, is 360 degrees. Okay, so let's find another quadrilateral, and I'll outline it in a different color. Let's look at the one on the bottom. There's a nice big one on the bottom. Okay, let's highlight that one in a different color. Let's say pink. So I'm going to go, there's 1 side, 2 sides, 3 sides, and 4 sides. So we're going to take all of the sum of the interior angles. So we have 53 degrees, 37 degrees, 90, 90, 56.3, and 33.7. And if we add those together, we also get 360 degrees. So the sum of the pink quadrilateral, just abbreviate that this time, is 360 degrees. So then we're asked to make a conjecture about the sum of the interior angles of a quadrilateral. Well, if we keep finding more, which in class we did do 3, we'll notice that the sum of the interior angles always is 360 degrees. So the sum of the interior angles of a quadrilateral is 360 degrees. Okay, so it worked for every single option that we tried. Next, we're now asked to identify at least 3 different pentagons. Hint, the pentagons do not need to be convex, so that means they can be concave. Find the sum of the interior angles for each pentagon. Recall that a pentagon is a 5-sided figure. So let's come down here and let's see if we can identify some pentagons. Okay, now let me see if I'm going to have to write over this. So let's choose green. Okay, so now let's find a 5-sided pentagon. So let's do 1, 2, 3, 4, 5. So my green figure is a pentagon. It has 5 sides. So we want to add up all the angles. That's the 33.7 degrees, 53 degrees. I'm sorry, my apologies, 90 degrees, 56.3 degrees, 33.7 degrees, 53 degrees, and add them all together. And what we notice is we're going to get 540 degrees. So let's write that down. Number 1, the green pentagon has a sum of 540 degrees. Okay, let's find one more so we can see how to come up with our conjecture. Let's see, I'll do yellow this time. So let's do 1, 2, 3, 4, 5. So we're going to add up all of those angles, and that's 93.3 degrees, 53 plus 90, 90, 90, 90, 33.7 degrees. And we should also get 540. So the yellow pentagon, let's make sure we're not using highlighter. Number 2, the yellow pentagon has a sum of 540 degrees. So let's make our conjecture, even though in class we did another one. We can make a conjecture that the sum of the interior angles of a pentagon will always be 540 degrees. The sum of the interior angles of a pentagon is 540 degrees. Great. Okay, then we're asked to see if we see a pattern in the sum of the angles of a polygon and the number of sides. Well, let's go back to a quadrilateral. We had a 4-sided quadrilateral, the sum was 360. We had a 5-sided pentagon, and the sum was 540. So what we notice is that if I take the number of sides, let's say n is the number of sides, and I multiply it times 180, and I subtract 360, I should get the sum. So let's try that with a quadrilateral. 4 times 180 minus 360. So I do get 360 there, and let's check that for the pentagon. 5 times 180 minus 360, then I will get 540. So if I know the number of sides in my polygon, I can find the sum of the interior angles by doing n, or 180n, minus 360. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.